All right. Start in one. We're going to be taking a look at exponential functions and how we work with them. Now, there are again certain properties that are always going to be present when we have these things. So to begin with, exponential function is always going to be in the form b to the x, something to the power that is going to be changed. Now the base, there are a few things that it cannot be. If b was equal to 1, would it really do anything? No. You could take 1 to whatever power you want and keep coming up with 1. And that's, one of the things that you have to worry about. B has to be a positive real number that cannot be equal to 1. Now, if it's positive, now if it wouldn't be positive, it would be negative. It'd be flipping all over the place, and we don't. That's a whole different situation. We just want to concern ourselves when that value is going to be positive and not equal to 1. Now, these are what the graphs are going to look like. So you need to make sure that you familiarize yourself. When you see a graph like this, hey, it's going to be exponential. It's either going to be going up where we have growth, or it's going to be going down when we have decay. And remember, this is always considered left to right. What direction is it going? What is it doing? So, transformations operate exactly the same way that we have taken a look at all of the other ones before. Simply because we go and change something, it's either going to move it up, move it left, move it right, flip it across. It's going to do some strange things. But they all apply the exact same way that we had done them before. It's either going to get applied to the y, or it's going to get applied to the x. Now keep in mind, when it gets applied to the x, like what we're looking at here, it goes into the exponent because that's where the x is. So x minus 4 moves it back this way. If I take a look at applying it to the y right here, that moves it up. So the expectation that we have is exactly the same as what we've done before. Nothing different here. Growth models. Now I had mentioned this before, that as it's going up, it's growing. When we start talking about growth, we're referring to, think about savings. You put some money in, you get a percentage back on your return, correct? I mean, that's interest. That's what's supposed to happen. It's supposed to grow, get more. If you take a look at a population, take rabbits in Australia. When rabbits were introduced, they're great, and then they exploded. They had exponential growth. They had no natural predators. So the growth exploded, not the rabbits themselves. Okay. Now, mind you, the value for B here is going to be greater than 1. You should be able to put it into your mind and say, okay, gee, if I take a number and I raise it to a power, what does this do? What happens to the numbers? If I put in 2, what's 2 squared? What's 2 cubed? What's 2 to whatever? Well, it's just doubling, getting a lot bigger and bigger and bigger and bigger and bigger and bigger. Growth model. Exponential decay. Now I want you to think about this for a second. If you keep losing half of something, do you ever really lose it all? One of the things that you have to understand about these things is that there's an asymptote. It goes here to the x-axis. Can it ever touch the x? What would it mean if it was touching the x or the x-axis? Well, that means that y would be 0. Is it ever possible to have a value for a that is greater than 0, a value of b that is between 0 and 1, and a value of k that is greater than 0 to get 0? These are multiplications that are going on there. So unless one of those is 0, you ain't going to get 0. That's why it says x-intercept none. Y-intercept is always going to be what happens when you put x in a 0, which in this case turns out to be a. So you have to have an idea in your head. What is this going to do? What is it going to look like? Now, there is another number, and we kind of talked about it a little bit, e. It's kind of like pi. It's a number that appears. Just happens to be there. Comes into play when we start looking at continuous growth. It's a number that appears. I'm not going to get in too technical with this stuff, simply because I want you to take a look at these problems and try and apply what's going on. See what happens with them. Okay? More of an exploration for you. You played with exponents before. You played with functions before. Now when you go through and take a look, which ones are exponential functions? Do they fit the pattern? What is the pattern? What have they done? Where have they gone? So I realize that I haven't provided you with much of anything, but make sure that you have this information in your head. Write it down, put it into your notes so that you can refer back to it, so you know what the basic shapes are going to be of exponential functions, and that you know what the basic formula or the basic function is going to look like. Okay? So I'm going to let you guys get to work on this.